Logic. Logic is the discipline that deals with the method of reasoning. According to Aristotle, logic is the science of correct reasoning. Symbolic logic, created by George Ball and appliances only to proposition. Proposition of declarative sentence that are either true or false.
Simple propositions. Simple propositions are propositions that convey one thought with no connective words. From the word itself, simple, ibig sabihin hindi mo na kailangan ng connective words para mapag-combine yung dalawang sentence. Example, Malolos is the capital of Bulacan. Dito sa example number 1, hindi na siya gumamit ng connective words, kumbaga naging straight to the point na lang siya ng thought na gusto niyang maiparating. Same ng number 2 and number 3 example. I will pass my math exam. January 10, 2024 is Wednesday. Compound propositions. Compound propositions are propositions that contain two or more simple propositions that are put together using connective words, such as and, or, not, if, then, and if and only if. Sa madaling salita, ang compound propositions ay ginagamitan ng connective words upang mapagsama ang dalawang simple propositions. Hindi katulad ng simple propositions na hindi na kailangan gumamit ng connective words para lang mapagdugtong ang sentence na ito.
These words, used to connect each of the individual statements to form a compound statement, are called connectives. Each statement of the compound statement is called a component statement. These are the examples of compound statements. Number 1 examples of compound proposition. 5 plus 3 is equals to 8 and 12 minus 7 is equals to 5. Number 2, today is Saturday or tomorrow will be Sunday. Number 3, today is not Friday. Number 4, if I will submit all the requirements, then I will pass this course. A proposition is a declarative sentence that is either true or false, but not both. For instance, the following are propositions. These are the examples of propositions. Number 1, today is Saturday. Number 2, I do not have a math class today. Number 3, 1 plus 1 is equals to 2 or 3 greater than 1. Number 4, all policemen are trustworthy. Number 5, today is Thursday and I have a math class today. Number 6, some cats have fleas. And number 7, if you will pass the exam, then I will give you a car. And number 8, Goku will have the Ultra Instinct if and only if he will train himself well. And note, questions and commands are not propositions.
Logical connectives mathematics works according to the laws of logic which specify how to make a valid deduction. In order to apply the law of logic in mathematical statements, you need to understand their logical forms. If you take a course of mathematical logic, you will see a formal discussion of proofs which starts with a formal language which describes the symbols you are allowed to use and how to combine them, and rules them in inference which describe the valid ways of making steps in a proof. Quantifiers and negations. A universal quantification is a type of quantifier, a logical constant in which an interpret as given any for all for any. It expresses the predicted can be satisfied by every member of the domain of the discourse. Existential quantifiers. Existential quantification is distinct from universal quantifications for all, which asserts the property of relation holds for all members of the domain.
Quantifiers are words or phrase that indicate the quantity or extent to which something is true. Example of quantifiers words are none, no, all, or, and etc. Now, ano naman po ang negation? It is the opposite statement o kabaliktaran po ng quantifiers. Example, quantifiers. All x are y. At ang negation po ay some x are not y. Here's the other example. Quantifiers. Some airports are open. And the negation is no airports are open.
Truth value and truth tables. The truth value of a proposition is either true or false, while the truth table is a table that shows the truth value of a compound proposition for all possible truth values of its simple proposition. Katulad ng sinabi nila nung unang nag-report, proposition siya kasi isa lang yung value niya and it can be true or false. Sa truth table, pinapakita natin lahat ng possible values ng propositions or set of propositions. So let's have the truth value for negation. Let's say na may statement ka na true. Once na inenegate mo siya, magiging false siya. Same thing if false naman ang statement mo, then kapag inenegate mo, so it turns to true. So next, truth value for conjunction. Sa conjunction, ang rule lang dito is kapag true yung dalawang proposition na pagdudugtungin mo, ito ay magiging true. Kaya kung makikita nyo rito sa example na aking nilagay, yung P ay true at yung Q ay true. Kaya kapag pinagtugtong mo yun, ang sagot doon ay true. Makikita rin sa pangalawang row na yung P ay false, yung Q ay true. Kaya yung conjunction niya ay false. Dahil nga yung rules doon ay dapat pareho silang true. May isang false, kaya ang sagot doon ay false. Lastly, the truth value for disjunction. Sa disjunction, maging true lang yung isang statement, true na agad yung sagot doon. Kaya sa example is yung P true, yung Q true. So, ang disjunction niya ay true. At kung titignan nyo rin sa pangalawang row ng example, yung P ay true, yung Q ay false, at tapos yung sagot sa disjunction niya is true. Kasi nga, once na meron lang isang true sa statement na yon, true na agad yung sasagot. Tautology. Ano nga ba ang tautology? The compound proposition that is always true and has a letter T in every row. Contradiction. A contradiction is a statement that is always false is known as a contradiction. A contradiction is a compound statement that is false for possible combinations of the truth values of its propositional variables. The contradiction is the proposition that is always false and has a letter F in every row. And also, from the word itself, contra. Conditional statement. A conditional is a logic compound statement in which a statement P, called the antecedent, implies a statement Q, called the consequent. Conditional is written as P if then Q and is translated as if P then Q. So dito, as you noticed in the table, ang only false lang dito ay yung may combination na true and false. Dahil if P is true and Q is false, then ang conditional proposition is false. Then the rest is true. Biconditional statement. A biconditional statement is a logical conditional statement in which the antecedent and consequent are interchangeable. A biconditional is written as P double arrow Q and it is translated as P if and only if Q. So, ang biconditional proposition is true if P and Q has the same truth value. Related statement. If we rearrange a conditional statement or change parts of it, then we have what is called related conditional. Ang related statement is all about changing the order of a statement. So, makikita natin dito sa table na meron tayong nakalagay na converse, inverse, contrapositive. Ano nga ba ang converse? Converse is switch order, while the inverse is negation. And lastly, the contrapositive is the combination of converse and inverse.
Here, let's take a look at this conditional statement. Let's break it down step by step. P and Q are both proposition. In this truth table, the first and fourth column are based on the truth values of P and Q. The last column is the negation of the second column. The third column represents the result of the conditional statement. The last column shows the resulting truth values based on the given propositions. Here, let's take a look at this biconditional statement. The biconditional statement, if P, then Q, and if P, then not Q, evaluates to true when only both implications are simultaneously true. In other words, it's true when P implies Q and also when P implies not Q. This happens only when P is false, as in this case, both P, then Q, and P, then not Q are true.
Symbolic arguments. An argument is formed with two components, a set of premises and a conclusion. The thing that we are being encouraged to believe is the conclusion, while the premises are the statements offered as supporting evidence for the conclusion that we want to make. Here are examples. Premise 1. If I do not have to go to summer school, then I will get an internship. Premise 2. I have to go to summer school, and the conclusion is I won't get an internship. Premise has like a similar word to theory or statement before the conclusion itself. It follows up to the conclusion. If the person doesn't go to summer school, then he will get an internship. If he goes to the summer school, then he won't get an internship. Basically the conclusion. Arguments and Euler diagrams. An argument can be classified as either valid or invalid. It's basically similar to the recent topic that we just discussed. On this part, we're using an Euler diagram to determine validity. In the following argument, is the following argument valid? Some students drink coffee. I'm a student. I drink coffee. The diagram shows that I can be inside the region for drink coffee or outside it. The argument is invalid. Here is the Venn diagram that shows two sides, like the other side is like people that drink coffee and students. The middle part is like the valid argument, and the two sides are like the invalid argument of the sides.
What is mathematics of logic? Mathematics of logic is the part of mathematics concerned with the study of formal language, formal reasoning, the nature of mathematical proof, probability of mathematics statement, computability, and other aspects of foundation of mathematics. Mathematical logic is also called logistic, symbolic logic, the algebra of logic, and also called formal logic. What is graph and Euler circuit? Euler path. An Euler path is the path that use every edge in a graph with no repeat. Being a path is does not have to return to the starting vertex. Euler circuit. An Euler circuit is a circuit that uses every edge in a graph with no repeat. Being a circuit, it must start in the end at the same vertex. So in the Euler path, it does not start in the same vertex, but the Euler path is, for example, A to E, from E to C, from C to A, from A to B, from B to C, from C to F, from F to E, from E to D, from D to A.
Why do we care if an Euler circuit exists? One of the example of that is the housing development loan inspector that were tackled on the beginning of the chapter. The loan inspector was interested in walking as little as possible. In this case, we can use the concept of Euler's path and its circuit theorem. As we know that the Euler's path contains at most two vertices of odd degree. Hence the graph that will illustrate the two odd vertices. Using the example of graph of Euler path, we can determine that the line that illustrate the circuit path of Euler's path contain two vertices with odd degree. Dots include for D and has vertices of A and D, B and D, and C and D. That means it has three odd degrees. And for E, it has only C and E that has 1 degree. Since it has one vertex, about this explanation using the Euler circuit example, we can conclude the related example about lone inspector that's seeking a shortest way or path to walk as little as possible. And this will be determined by illustrating first the path using the line represent the vertices that will help us to determine the distance, its degree of its paths. And this concludes my explanation about Euler's path and Euler circuit. How do we care? How do we care and how it's work in real life situation? We will proceed to the next topic related also about Euler circuit, and it is all about Euler's formula that will be discussed with the next reporter.
Euler's formula. In the world of complex numbers, as we integrate trigonometric expressions, we will likely encounter the so-called Euler's formula, named after the legendary mathematician Leonhard Euler. This powerful equation deserves a closer examination. In order for us to use it to its full potential, we will take a look at how Euler's formula allows us to express complex numbers as exponentials and explore the different ways it can be established with relative ease. The way how its use is. And since it's raising a unit, complex number to a power can be thought of as repeated multiplications, i.e. or adding up angles in this case. Euler's formula can be constructed as two different ways of running around the unit circle to arrive at the sum point. So Euler's formula is basically used for determining the relation between the bases and verticals of polyhedra, and in the trigonometry, Euler's formula is used for tracing the unit circle, hence the circle in the image shown.
So what exactly is Euler's formula? To put it simply, it is a theorem that states that x is a real number, e is the base of the natural logarithm, and I is the imaginary unit that is the square root of -1. Now, let's take a look at the key values of the Euler's formula and see how they correspond to the points of the trigonometric unit. For x equals 0, we have e equals cosine I sine, which gives 1 equals 1. For x equals 1, we have e raised to I equals cosine 1 plus I sine 1. For x equals 2 pi, we have e raised to I times 2 pi equals cosine 2 pi plus I sine 2 pi. For x equals pi, we have e raised to I pi equals cosine pi plus I sine pi. So, what is graph coloring? As you can see, this is the definition of graph coloring. So, graph coloring is an assignment of labels called colors to the vertices of a graph such that no two adjacent vertices share the same color. The study of graph coloring has historically been linked closely to that of planar graphs and the four-color theorem, which is also the most famous graph coloring problem. These are some examples that uses graph coloring: computer science, information technology, and complexity theory. Many day-to-day problems like minimizing conflicts in scheduling are also equivalent to graph colorings. Now, let's talk about chromatic numbers. Chromatic numbers are the minimum number of colors needed to color a graph is called a chromatic number. For example, the graph here can be colored a minimum of 2 colors. Graph coloring problem is both a decision problem as well as an optimization problem. A decision problem for a class of question in mathematics and formal logic, the problem of finding after choosing any question of the class an algorithm or repetitive procedure that will yield a definite answer, yes or no, to that question. An example would given M colors and graph G whether a such color scheme is possible or not. Now, the basic idea of optimization problems is we have a particular quantity that we're interested in maximizing or minimizing. For example, given M colors and graph G, find the minimum numbers of color required for graph coloring.